Hi and welcome to my OCR A-Level Biology revision session with me, Christine. So today's lesson I want to look at temperature control in endotherms and ectotherms, but I want to take a step back and remind ourselves about the heat transfer between the body of an organism and its environment, and the fact that this is dependent on the temperature difference between that organism and its surrounding. So when we look at, for example, the loss or gain of heat, we can look at it through the fact of radiation. So radiation is this heat transfer in the form of an electromagnetic wave, mainly infrared radiation. It comes from the sun, we see it in our sunny, hot days, but we ourselves also radiate heat out to the environment because our body temperature in our core is normally hotter than the room temperature for which we're in. Obviously, as you go to warmer climates, that may be less the case, but you will see that we radiate thermal energy from our bodies. Now, another way in which we can lose or gain energy is through the process of conduction. So conduction happens in solids. So this is where there is a physical touch between the particles. So if we're looking at ectotherms and they physically touch a warmer ground, that thermal energy will go from the ground through the particles in their body, and that will allow them to warm up. If you think about on a cold day when you are holding a mug of coffee or tea and the thermal energy from the cup is being transferred to your body through that process of conduction. Now, another way in which we can lose or gain thermal energy is through convection. So convection is where we heat something up. The particles close to that heat source are going to gain thermal energy, get kinetic energy, and that warm air will rise up. Now, it's not just air, it can also be the same in water. Now, if it's colder, what's going to happen is that cool air or water is going to sink down, and what we get is this convection current occurring. So the warm air is always rising. As it cools down, it's then going to sink back down again. So we end up with this convection occurring in air and in water. Now, the other one we need to know about is evaporation. So we know that evaporation is this loss due to the conversion of water into water vapor. So let's remind ourselves about module 2 and that high latent heat of vaporization. So the high latent heat of vaporization mean that there's lots of energy needed to break the bonds, the hydrogen bonds, the cohesive property in water. So because we have lots of energy needed to break those bonds, that works as a cooling effect. So we need to know the difference between an ectotherm and an endotherm. So an ectotherm is all the different organisms like invertebrates, fish, amphibians, reptiles, and they use their surroundings to warm their body up. And that's because their body temperature is actually dependent on that environment. So if the ambient temperature around them is 10 degrees C, their body temperature will be close to 10 degrees C. So as the ambient temperature increases, so does their body temperature. So they need to have some behavioral responses that allow them to adapt, because they don't want to get too hot, because remember, high temperature affects our protein structure, therefore affects our enzymes and our chemical reactions. That's the same with ectotherms. If we go to too low temperatures, we're going to have not enough kinetic energy. There's not enough kinetic energy. Chemical reactions can't occur in a optimal state. So therefore, ectotherms have got some behavioral responses when their environment changes. Now, that could be things like basking, where they orientate themselves to the sun, expose the surface area so that they can maximize that absorption of that radiation that came from the sun. So an ectotherm will bask in the sun, they will orientate themselves. But what you need to know is that actually if it gets too hot, they will also need to orientate themselves, but this time they may decrease that surface area being exposed. They can lower their body or raise their body, so that's linked to the conduction. If they lower their body, they are going to be touching the surface of the ground. If that's the case, they're either going to be heating themselves up if the ground is warmer, or cooling themselves down if the ground is colder. By raising or lowering their body, they are able to either have that conduction or reduce the conduction. So remember, it's about increasing or decreasing that thermal transfer. They can seek shelters, they can seek the shade, they can go into cracks in rocks and burrows. The reason being is when they go into the shade, there is a smaller fluctuation in that temperature. It's only about 5 degrees C, so they are therefore reducing the effect that thermal energy will have on them. And also, if they are organisms that live in the water or organisms that can go back to the water, for example, our reptiles or our amphibians, if they go back to the water, what we understand is that with the water, there is a high specific heat capacity. Because there's a high specific heat capacity, remember that links back to module 2, that means that there is a lot of energy that is needed to actually raise the temperature in a body of water by 1 degree C. That makes the water a very stable environment. And because it's a very stable environment, they can go back to that environment if they want to cool down. So it's a behavioural response where they're returning to the water to cool themselves down if the temperature has risen too much. Now, there are some physiological responses, but they don't expect you to know these for the exam. But if they do want to test you on them, it will be linking them to other areas. So, for example, skin colour. There are some organisms that will have a way in which they can change their skin colour so that they are either absorbing more radiation or absorbing less radiation. So, for example, dark colours are absorbing the radiation more, light colours will reflect the radiation. So that's your GCSE knowledge coming in. If they're going to look at that, they will be linking to the fact that the skin colour is produced by it's a pigment that's produced in the skin, so it's produced through the process of transcription and translation. Bradycardia, this is module 3 coming in here. They'll be expecting you to understand if you've got an organism that has bradycardia, why is that good? That's going to reduce the heart rate, reduce the blood flow to the periphery. That therefore is going to be a way in which they can maintain that thermal energy inside their body. So that would be a way in which they are responding if the ambient temperature gets too low. Also, they can have low metabolic rate. Now, this low metabolic rate means that they have a less energy demand, so they require less food. Now, this is an interesting one because this links to your ecosystem topic area of module 6. But what it does mean is that these ectotherms can be found in different environments because they don't require as much energy. Therefore, they don't require as much food. So you can find them in lots of different places, but they wouldn't thrive in those places if they don't have the ability to move away from the external temperature which would cause them problem. So you only need to know for the ectotherms about the behavioural responses, but be aware that they could apply the knowledge of the physiological responses by linking them to other topic areas. So our endotherms then are our mammals and our birds. Now, they rely mainly on the metabolic processes that occur inside the body. That's why they're called endotherms. So therefore, they are using the metabolic processes 5 times greater than an ectotherm. And they're maintaining their body temperature at a constant level. They can survive in a wide range of environments because they are able to use physiological processes. So there are some behavioural responses that you need to know when it comes to an endotherm. Things like being dormant during periods of high temperature or low temperature, uses of burrows, houses and shades, methods to warm or cool those burrows or houses. So it could be that they are trying to ensure that these burrows and houses are warmer. So what are the methods of warming them up? Well, it's things like using materials that, if they're wanting to warm the interior, using things that would insulate their burrows. If they're talking about cooling it down, it would be about allowing air to circulate. So having air holes, like us having our windows and our doors to ventilate our houses, the animals, the endotherms, will also have the ways in which they are going to ensure that they are able to insulate their burrows and houses or allow for the air to come in or out. So giving a method of that behavioural response is a good part of the answer process. They also do things like they can do wrist licking, where they are taking some of their saliva and they are putting it onto the surface of their skin. Now that saliva, by licking the wrist, that is going to then link to evaporation. If the saliva is on the wrist and that water is going to be converted into water vapor, it will then evaporate. That will take away the thermal energy. So that is a behavioral response. Obviously, wearing clothes, when we talk about humans, depending on the weather, we can wear clothes if it's really cold outside, or if it gets warm, we can take a layer off. So therefore, our behavioral response is the fact that we wear clothes or that we remove clothing when it gets a different level. What you can also have a behavioral response of endotherms, for example, is this migration, where organisms will move to a warmer climate or they can move to a colder climate depending on what that migration is necessary for. But this is a behavioral response where they are moving and migrating. The other thing to think about is huddling. So if we look at penguins, penguins will huddle, and that is a way in which they are behaviorally responding to the external environment. As it gets colder, by huddling together, they are therefore exposing less surface area and therefore losing less energy to their environment. Now, the physiological responses, there are quite a lot. So I have actually done a whole video on the physiological responses, but just to list them here, there are things like vasodilation, vasoconstriction, sweating, insulation by feathers and hairs, or shivering. So these are all the physiological responses, but I've done a whole another video on these responses because you do need to know them in more detail. So I hope you've liked this video, and if you have, then please do click on the like button and subscribe to my channel. And if you haven't already done so, please do check out www.aiqchat.com.